In this video, I'll be going through 4 different problems involving multiplying polynomials. As we go through them and you start to get more and more confidence with each one, I suggest that you pause the video and try the next one on your own before I go through it. So let's start with this first one. We have the quantity of 2x squared plus 3y all squared. The first thing that we want to do with this problem is write it out expanded. So this square up here means that we're multiplying this entire term in the parentheses to itself. So we have the quantity of 2x squared plus 3y times the quantity of 2x squared plus 3y. And now that we have it set up like this, we can use the box method, we can FOIL, or my preference is to use the distribution method, which says we're going to take our first term and distribute it to every term that's being added and subtracted, and then we're going to take our second term and distribute it to every term that's being added and subtracted, which gives us 2x squared times 2x squared is 4x to the fourth. So remember, you multiply your coefficients in front. 2 times 2 is 4. Then you keep your variable x, and you add your exponents of your variable. Whenever you're multiplying the same base, you add the exponent. So 2 plus 2 gives us x to the fourth. Now let's keep going. 2x squared times 3y gives us plus 2 times 3 is 6. And then x squared and y are unlike bases, so we cannot combine them. We just get x squared times y plus 3y times 2x squared. 3 times 2 is 6. And then y times x squared is just x squared y. Again, we cannot combine these terms together. And finally, 3y times 3y. So 3 times 3 gives us plus 9. And y times y is y squared. Again, you keep the base, which is y, and you add the exponents together. 1 plus 1 gives us 2. Now we just want to check if there's any like terms that we can add together. And in this case, we have a 6x squared y plus 6x squared y. Those are like terms, so we can combine them, giving us 4x to the fourth plus 12 x squared y plus 9y squared. And this is the completely simplified form of 2x squared plus 3y all squared. Okay, now for the second problem. And again, I suggest you pause this and try this out on your own if you're feeling a bit more comfortable with it. So 5x plus x squared times x minus 2x cubed. This 5x, we're going to distribute it to each term that's being subtracted here. And then again, we're going to distribute the x squared, just like we did in the last problem, which gives us 5x times x is 5x squared minus, because we have a positive times a negative, we get a minus. 5 times 2 is 10. Then x times x cubed is x to the fourth. Then we have plus x squared times x is plus x cubed. And finally, plus x squared times negative 2x cubed is negative 2x to the 2 plus 3 is 5. In this case, we do not have any like terms. We have x squared, x to the 4th, x cubed, x to the 5th. These are all unlike terms because they have different exponents, so we have to rewrite them in order by exponent. Remember, whenever you have only one variable, you start with your largest exponent and then work your way down. So our largest exponent is this negative 2x to the 5th, so we'll start with that. Then our next largest is x to the 4th, so we put minus 10x to the 4th. Then plus x cubed. And finally plus 5x squared. And that is the completely simplified form after multiplying 5x plus x squared times x minus 2x cubed. Now we'll move on to the third problem. X minus 2 times x squared plus 2x plus 4. Just like before, we're going to distribute our first term to everything that's being added and subtracted, and then we're going to distribute our second term. Even though this one has a 3-term polynomial or a trinomial, it will still work out with the same rules as before. So we have x times x squared is x cubed. X times positive 2x is plus 2x squared. X times 4 is plus 4x. And now we're going to multiply this negative 2 to each term. So we have negative 2 times x squared is negative 2x. And a little trick that you can do is start writing each like term below the like terms that you already have. So negative 2x squared, we're going to put it below the positive 2x squared we have from multiplying our first set. Then negative 2 times 2x gives us minus 4x. We're going to put that below this positive 4x we have here. And then finally, negative 2 times 4 gives us negative 8. We do not have a constant in our first set, so we're just going to write that negative 8 at the end, away from all the other terms. And now we're just going to add these two polynomials together. X cubed plus nothing is x cubed. Positive 2x squared minus 2x squared is just 0. So we'll just put a 0x squared here. Positive 4x minus 4x is again 0x or just 0. And then negative 8 plus nothing is just negative 8. So we get x cubed minus 8. That is the completely simplified form of this problem after multiplying. Note that we did not have to write out these 0x squareds. I just did it so that you wouldn't be confused as to where these terms went. Okay, the last problem that we have is this x squared plus x plus 1 times 2x squared plus 3x plus 2. Whenever you're multiplying two trinomials together or two polynomials that are bigger than a 3-term polynomial, I suggest using the box method. And the box method says we're going to take each of our terms in our first polynomial and we're going to write them out without addition. So we have x squared plus x plus 1. We're just going to write out x squared x and 1. If one of these terms were minus x, for instance, then you would put the negative with your x. But in this case, they're all positive, so we just drop the positive signs. Now we're going to write out the second polynomial long ways, so vertically. So we have 2x squared, then 3x, then 2. And now the trick with this type of problem is we want to create a box containing all of these terms. And for every row you have, you're going to make a row in the box. So we make a row for the 2x squared, a row for the 3x, and now we automatically just made a row for the 2. So we have 3 rows, 3 terms, and now we're going to make a column for each term. So this x squared gets its own column, and this x gets its own column. In each of these boxes, we are going to multiply the respective terms. Meaning, in this top left box, we have 2x squared times x squared. That gives us 2x to the 4th. In this box, we have 3x times x squared. That gives us 3x cubed. And finally, in this box, we have 2 times x squared gives us 2x squared. And now we're going to repeat this process for every box. In this box, we have 2x squared times x, which is 2x to the 3rd. In this box, we have 3x times x, which is 3x squared. Here we have 2 times x, or just 2x. And then finally, in this entire column, every term is being multiplied by 1, so we're just going to keep exactly what we have, meaning we're going to have 2x squared, 3x, and 2. And now we just want to go through this entire list, adding our like terms together. So we have a 2x to the 4th. No other term has an x to the 4th. So we get 2x to the 4th. Now we have 2 terms that have an x cubed. So 3x cubed plus 2x cubed gives us plus 5x cubed. Then we have 2x squared plus 3x squared plus 2x squared. All of them have an x squared. So that gives us 2 plus 3 is 5. Plus 2 is 7, so plus 7x squared. Then we have 2x plus 3x is plus 5x. And finally, we have a 2 by itself that gives us plus 2. And this polynomial is already in order for us. We do not need to sort it by exponent. And we do not need to worry about adding common terms together like we did in the last problem, as it's taken care of for us in this box process.